Day 7, now time for our final flipped classroom lesson on thermal energy. And then it's time for a test. But right now, let's get through thermal energy in a cold climate. We certainly go cold in the Greater Toronto Area this year. It may seem easy. Donut-munching, hockey-loving Canadians are living in a cold climate can be very challenging. Animals can migrate, hibernate during the cold months, or use their fur coats to survive. For humans, it has taken many years and many innovations to learn how to survive in a cold climate. Some methods of survival have been around for thousands of years. Fire is one of the oldest sources of thermal energy. Humans soon found that open fires are hard to control. Winds can make the flame move in unexpected ways, or just extinguish the fire. Fortunately, we live in homes with heating systems. However, most of the heating systems we take for granted were invented only within the last 50 years. Have you ever wondered where the term warm-blooded or cold-blooded comes from? They're not just words made up by old people. Humans are warm-blooded creatures. Warm-blooded creatures get their thermal energy from the food which they eat and from the exercise performed by the cells in their bodies. The warm-blooded creature has a complex control system that works very hard to maintain the thermal energy that is stored in the creature's body. Of course, this control system does need assistance. For example, in winter, you need to wear warm clothes to help your body keep thermal energy inside. Here's a question for you, Day 7. How are the ways that a polar bear is formed different from the ways that a tree frog is formed? Let's look at cold-blooded animals for that answer. Reptiles, fish, and amphibians are referred to as cold-blooded creatures. Actually, their bodies are usually quite warm. However, in cold temperatures, these creatures have difficulty surviving. They cannot produce enough energy inside their body in order to maintain a constant body temperature. In order to survive, they need to be in a warm environment with a warm temperature, or live in an area where there is lots of exposure to the sun, or simply learn to live with a lower body temperature. Animals have learned to rely on their adaptations in order to survive. Polar bears use their fur to keep the heat inside their bodies. Some animals use their surroundings as heating storage. Small animals, for example, can dig tunnels and live under the snow. The snow actually acts as an insulator. The animals find the tunnels quite warm. Humans have two methods of keeping warm inside. The first method is radiation. Walls of shiny covered metal absorb heat and keep a building warm. Another method is conduction. Air is a very poor heat conductor, so home insulation is made with air spaces that keep heat from escaping through the walls of the building. Now, look at these two gentlemen. They're not wearing garbage bags. These jackets are made out of materials that absorb heat and prevent body heat from leaving the body, making them very toasty warm. Convection can occur within a home, and it can cause heat. Air pockets get too large and allow heat to escape. So home insulation has to be made of material that creates tiny air pockets to keep heat from escaping. If warm air escapes through an opening in a building or clothing, colder air will replace it. In order to prevent air leakage, Cracks in walls need to be sealed. Clothes must be made with elastic cuffs or ties to prevent the loss of body heat. Water vapor is a natural occurrence, but it needs to be controlled in order to maintain heat. Water vapor travels through outside walls and condenses as it enters the building. Also, water vapor makes the materials in the walls better heat conductors, in turn cutting down on the thermal energy which is produced. Fortunately, engineers have found materials to use to make walls relatively moisture-proof. Now, here's some things to think about for next class. What are 3 things that you could do when you are inside to help you stay warm? And what are 3 things that you could do when you are outside to help you stay warm? Something to think about, grade 7. Don't forget your test, which is coming up. See you then. Bye-bye.